Hello everyone. In previous class we discussed about refraction. So to explain the process of refraction, we need to know about the constant is called as refractive index, which is the property of a transparent medium. Let us learn about it. The extent of the change in the direction that takes place when a light ray propagates through one medium to another medium is expressed in terms of refractive index. What is the meaning of refractive index? Now we will discuss. Light travels in vacuum with a speed nearly equal to 3 into 10 to the power of 8 meter per second. It is denoted by a letter C. The speed of light is smaller than C in other transparent media. Let V be the speed of a light in a certain medium. Then the ratio of speed of light in vacuum to the speed of light in that medium is defined as refractive index n. It is called as absolute refractive index. The speed of a light in vacuum is denoted by C, and let V be the speed of a light in a certain medium. Then the ratio of speed of a light in vacuum to and the speed of a light in that medium is defined as refractive index. It is denoted by n. It is called as absolute refractive index. So we can write the formula of refractive index like this also. Absolute refractive index equal to speed of a light in vacuum by speed of a light in medium. So we know that refractive index is showed by n. N equal to C by V. Okay, so we can write a refractive index n equal to C by V. N is nothing but refractive index, and C is nothing but speed of a light in vacuum, and V is nothing but speed of a light in medium. Refractive index gives us an idea of how fast or how slow the light travels in medium. Refractive index gives us an idea of how fast or how slow the light travels in a medium. The speed of light in a medium is low when a refractive index of the medium is high, and the speed of a light in medium is high when the refractive index of a medium is low. If the speed of a light in medium is low, then the refractive index is high. If the speed of a light in medium is high, then the refractive index is low. For example, the refractive index of a glass is 3 by 2. Then the speed of a light in glass is 2 by 3 of 3 into 10 to the power of 8 meter per second, or equal to 2 into 10 to the power of 8 meter per second. The refractive index of a glass is 3 by 2. Then the speed of a light in glass is equal to 2 into 10 to the power of 8 meter per second. Means here nothing but refractive index is denoted by n. No, in the place of n we have to write 3 by 2. Okay, and C value we know that. Okay, what is that? C value 3 into 10 to the power of 8 meter per second. So 3 by 2 equal to 3 into 10 to the power of 8 meter per second by V. So here by this we can identify the speed of a light in glass also. Okay, n equal to C by V is there. If the refractive index of a glass is 3 by 2, then what is the speed of a light in glass? Can we identify? Yes, we can identify. How? Here refractive index value n equal to 3 by 2 is there. No, that is substitute in the above formula refractive index. What is that formula? Refractive index formula n equal to C by V. So n equal to substitute 3 by 2, and C equal to 3 into 10 to the power of 8 meter per second. No, what is that? C means speed of a light in vacuum, that is denoted by C, that equal to 3 into 10 to the power of 8 meter per second. So this value substitute in the place of n and C. By this we can identify the V value. V is nothing but V is the speed of a light in certain medium. So here medium is glass. No, why? Because he is asking us to calculate the speed of a light in glass. Glass is one of the medium. Okay, So what is the speed of a light in glass? We have to identify glass is one of the medium that is denoted by V. So the above values of refractive index and speed of a light in vacuum, that C value and N value substitute in the above formula. Refractive index N is equals to C by V. If we substitute in that formula, then we will get N is equals to 3 by 2 equal to C is equals to 3 into 10 to the power of 8 meter per second divided by V. Okay, do cross multiplication. 3 into V equal to 2 into 3 into 10 to the power of 8 meter per second. So here 3 is multiplying. Now if you transport this right side, it will divide. So V equal to 2 into 3 into 10 to the power of 8 meter per second by 3. 3 will get cancelled. Then V is equals to what will come? 2 into 10 to the power of 8 meter per second. Means the speed of a light in glass slab is 2 into 10 to the power of 8 meter per second. In previous class, we discussed one activity. What is that? When light travel from rarer medium to denser medium, then the refracted ray move towards the normal. Okay, and when the light travel from denser medium to rarer media, then the refracted ray move away from the normal. We discussed, Now we'll observe that with one activity. Okay, so what is that activity name? Obtaining a relation between angle of incidence and angle of refraction. So what is that activity? Obtaining a relation between angle of incidence and angle of refraction. So to perform this activity, we need a white chart, a wooden plank, and protractor, scale, small black painted plank, and a semicircular glass disc of thickness nearly 2 cm, pencil and laser light. So to perform this activity, we need one plank, white chart, protractor, scale, semicircular glass disc of thickness nearly 2 cm, and pencil and laser light. Okay, so how can we perform this activity? Now we will discuss. Take a wooden plank which is covered with white chart. Now draw two perpendicular lines passing through the middle of the paper as shown in the figure 4a. Okay, first we took one wooden plank. That wooden plank is covered with white chart, and we drawn two perpendicular lines. That lines are passing through the middle of the paper as shown in the figure. Let the point of intersection be the O. Okay, the point of intersection be O. Here we drawn two perpendicular lines that are passing through the middle of the paper. The point of intersection of these 2 points is O. Mark one line has NN as shown in the figure, which is normal to the another line. Okay, which is normal. Okay, so mark one line has a NN. In this figure we can observe one vertical line. Mark that line has a NN, which is acting like a normal. And another line is marked as MM. Horizontal line is there, that we should mark as a MM. Here MM represent the line drawn along the interface of two media, and NN represent the normal drawn to this line at O. So here this MM and NN is there, that NN represent the normal, and MM we drawn one line, that line is nothing but that separating the two mediums. Take a protractor and place it along NN in such a way that its center is coincide with O as shown in the figure 4a. Then mark the angles from 0 degrees to 90 degrees on both sides of the line NN as shown in the figure. Okay, now take a protractor and place it along NN in such a way that its center is coincide with O as shown in the figure. Then mark the angles from 0 to 90 degrees on both sides of the line NN as shown in the figure. Repeat the same on other side of the line NN. Okay, the angle should be indicated on the curved line. So here in this figure we can observe NN line. So here both sides of the NN, okay, NN right side we should mark the angle 0 to 90 degrees. So and left side also we should mark the angle 0 to 90 degrees. Okay. Now place a semicircular glass disc so that its diameter coincide with the interface line MM and its center is coincide with the point O. So now take a semicircular glass disc so that its diameter coincide with the interface line MM and its center is coincide with the point O. In figure 4th B, once you observe, we took one semicircular glass disc. So that's diameter coincide with the interface line MM. Okay, MM line is there, no? That MM line, what is that line? That line is nothing but that separating the two mediums. Means here on that MM line, we place one semicircular glass disc. Okay, so that glass disc one of the medium. MM upside, MM line upside, semicircular glass disc is there. That glass disc is one of the medium. MM line downside, nothing is there. That is one of the medium, means air medium. Okay, so and the semicircular glass disc center is there, no? That is coincide with the point O. Now point a laser light along the NN in such a way that light propagates from air to glass through the interface at a point O and observe the path of the laser light coming from other side of the disc as shown in the figure 4th B. So if you cannot observe the path of a laser light, put a black colored plank against the curved line and observe the light point and imagine the light path. So here nothing but here NN is acting like a normal. MM is horizontal line is there, no? That MM line is separating the two mediums. So where is that two mediums? Here we took semicircular glass disc, no? We should place that semicircular glass disc on the MM line. Horizontal line is there, no? On that line we should place the semicircular glass disc. So MM line upside, semicircular glass disc is there. That glass disc is one of the medium. MM line downside, nothing is there. Air is there. Air is one of the medium. Okay. So now we should take a laser light. Okay. So pass the laser light from air to glass disc. Okay. Means now we are sending light from one medium to another medium. Okay. We pass the laser light from air to glass disc. Okay, so means now we are sending the light from air to glass disc, means from one medium to another medium we are sending the light. Okay, so we know that when the light travel from one medium to another medium, its speed is changing, at the same time its direction also changing. Okay, that we can observe in this activity. Once you observe the picture, white colored path line is there, no? So light path, white colored light path is there. Okay, means we are sending the light from air. That light strikes at the point O and pass through the glass disc. Finally it is coming from the outside of the semicircular glass disc. After the glass disc, again we can observe light path. So here the light path is changing its direction or not. So we can say this is one of the example for refraction. Okay. So if you cannot observe the path of laser light, put a black colored plank against the curved line and observe the light point and imagine the light path. So is there any deviation? Now send a laser light along the line which makes 15 degrees angle of incidence with NN and see that it passes through the point O. Measure the corresponding angle of refraction. By observing the laser light coming from the other side of a circular disc of a glass slab, next note these values in table 2. Do the same angles of same for the angles of incidence such as 20 degrees, 30 degrees, 40 degrees, 50 degrees and 60 degrees and note the corresponding angle of refraction. So here we are sending the light from air. Okay, so that falls on the point O. Okay, and after that is entering into the glass disc and finally it will come outside. So first we should send the incident light from 15 degrees. Already we are marked the angles, no? We marked the angles both sides of the normal. NN line is normal, that right side we mark the angles, and NN left side also we should mark the angles. So here upside glass disc is there, downside air is there. So here first we should send the light from air from 15 degrees. Okay, we should send the laser light from air medium at 15 degrees. So first we are sending from 15 degrees. Now that is called as angle of incidence. Angle of incidence is nothing but the angle between the incident ray and normal is called as angle of incidence. So now we are sending the light at from 15 degrees, then it falls on the point O. Finally it will come, it will travel through the glass slab, finally it will come outside. That time how much the angle of refraction we can observe. Why? Because light path coming outside, now from the path we can observe how much the angle of refraction. So like that we should send the incident, we should send the light, means incident light from 20 degrees, 30 degrees, 40 degrees, 50 degrees and 60 degrees. So then measure the corresponding angle of refraction, then also it will come outside. Now then how much the angle of refraction, it means first we are sending the light from 15 degrees, next to from 20 degrees, next to 30 degrees, next 40 degrees, next 50 degrees, like this we are sending. Then angle of refraction also changing. Now measure the angle of refraction value. Note that values in table 2. I is nothing but angle of incidence, R is nothing but angle of refraction. Okay, so I for example 15 degrees, R is 30 degrees is there, and right here sine 15 degrees, sine I nothing but sine 15. What is this value? We should note. Sine R is refractive. For example, I is 15 degrees, no, R is 25 degrees, like R is 30 degrees is there. Okay, I is 15 degrees, or I is 15 degrees is there, and measure the angle of refraction value. Okay, and sine I is nothing but sine 15. Sine R is nothing but angle of refraction, how much is there, that value we should mention. Okay, and find the ratio of sine I by sine R. I value is for example 15 degrees is there, R value is for example 10 degrees is there. Okay, I value is 15 degrees and angle of refraction value 10 degrees is there. So then sine I means nothing but sine 15, sine R is nothing but sine 10, and find the ratio of sine I by sine R. We will get one value. Okay, so we know the sine values from the trigonometry chapter from 10th class maths. So sine 15 value how much, sine 10 value how much, that we should find out, and find the ratio of sine I by sine R. Okay, I is equals to 15 degrees, R is equals to 10 degrees. Okay, angle I is equals 15 degrees, angle R is equal to 10 degrees. Sine I is nothing but sine 15, sine R is nothing but sine 10, sine 15 how much value is there, sine 10 how much value is there, that we should find out from the trigonometry chapter from 10th class mathematics, and finally from that substitute that values and find the ratio of sine I by sine R. So we will get one value. Okay, so this ratio gives the values of refractive index of a glass. Okay, this ratio gives the values of refractive index of a glass. In the above experiment, you might have noticed that the R is less than I. Angle of refraction is less than angle of incidence. Okay, in all cases, and the refracted ray bends towards the normal in each case. Okay, so from the above experiments, we can say like this: angle of refraction value is less than angle of incidence, and the refracted ray is bends towards the normal. So in previous activity, light travel from rarer to denser media, the refracted ray is bends towards the normal. From the above experiment, we can conclude that when the light travel from rarer medium like air to denser medium like glass, the value of R is less than the value of I. Means angle of when the light travel from rarer to denser media, angle of refraction value is less than angle of incidence, and the refracted ray is bends towards the